Is this your first thing after the Hangout-a-thon?
First thing after the Hangout-a-thon and dealing with about 900 of the 1,500 emails I got over the weekend.
Yes, yes. Not only can you not put your life on hold over those kinds of things, but in fact, it creates this gigantic black hole of time.
Well, vacations do the same thing, and if
Yeah.
I'm going to be punished for taking time off, I'd rather have the time away from my computer be something that helps my job rather than something that simply leaves me feeling like, oh crap, I can't leave my job behind ever.
I always envy those people that can like take actual vacations and other people do their jobs while they're gone, you know?
Yeah, we aren't those people.
No, we're not. No, no. If I leave, I get, 200 or 300 emails a day. And so if I leave, then they're waiting for me.
hmm And you still have to answer them. And, no matter what away message I put up, people still, they'll start like sending me emails that say urgent, that say
Urgent.
respond immediately. And if I'm not there, I'm not there.
But anyway, congratulations on
Thank you.
32 hours of hanging out a thon madness. And
Yes.
I watched as much as I could. I participated as much as you'd let me. And you guys did a great job.
Thank you. Thank you. It was a long weekend and we still have a long road to go on our fundraising, but we hit 10% of our total goal, which is pretty good.
Yeah, it was great to see everyone's support. There was a few really great guests who were able to really help with the fundraising. So no, I thought like, for the first time, we've done this kind of a thing. I think you guys did a great job.
Yeah,
I'm really
Jeff
impressed.
Notkin, one of the Meteorite Men, more than anyone else, came on and fired up the audience. And Michael Foister from Astronomy FM, he was there behind the scenes for
Yeah.
almost the entire 32 hours. He stopped to go do his day job, but Astronomy FM, they were huge supporters both on the technical side and then they also rebroadcast everything we did. And some of that must have been really weird on radio, for instance, when I completely failed to make cake pops that look like planets.
I caught that part.
Yes, that was just bad.
So we're going to record two episodes now. We're going to record right now. We're going to do an episode on climate change, and we tried to do one during the Hangout-a-thon, but I think our sort of the audio wasn't very good,
Yeah.
and our guest wasn't exactly sort of prepared in sort of the way we tend to do our episodes. So we're going to sort of take another crack at the climate change now.
Yeah,
Uh,
our guest was good. We were the ones, we didn't prepare
yeah,
her for how we normally do this as a let's discuss the science facts.
yeah, yeah.
So she took it from a much more pragmatic sociological perspective.
And I love to have that conversation too, but it didn't really feel like it was
It's
going to
not
fit with
this
the Astronomy
show.
cast. Yeah, so it's still in the feed for the Hangout-a-thon,
Yeah.
but we're going to do the sort of the science side of it with this episode.
I just realized my cup's completely empty. I'm going to run to the other side of the wall and back with
Okay.
some water.
All right. Well, then I will continue my various spiels then.
Okay.
Right. So then after that, we're going to do another episode on creating a sciencey society, and I think this is something that's quite near and dear to all of our hearts, which is like how do we get people more enthusiastically engaged in science, not necessarily just astronomy, but just all of the sort of wonderful benefits of science that we all live and experience. How can we get people to really kind of appreciate it and encourage it and stop teasing us. So I think that's what we want to try and encourage. The other part that you should know is this is an interactive experience. So we're going to record Astronomy Cast, and we will probably make a bunch of mistakes, and you get to watch that, which is always hilarious. But if you want to suggest any ideas, if you want to ask us any questions or want to make some comments, you absolutely can do that. Just you can post your comments. If you're watching this on the event page on Google+, you can post a comment there. If you're watching this on the in my stream, you can post a comment there. If you're watching this over on YouTube, make a comment there. Or if you're just watching this somewhere else and you just like Twitter, then just use the hashtag AstronomyCast, and we will catch all of those locations, I hope. I also want to remind you, if you're watching this, to just click subscribe in whatever YouTube you are experiencing this in. So, all of the shows, they start out on my feed, and then they end up over at Astrosphere Vids. So either, subscribe at Universe Today on YouTube, but also subscribe at Astrosphere Vids on YouTube, and that way you'll get the
Yeah.
sort of the nice full sort of archive of all of our videos. So, and then as new ones are posted, you'll see them there. Not that we don't also love the audio listeners as well, as we're trying to streamline the whole process. We're almost caught up actually by the 2 episodes we do tonight, and there's one that we've got sort of to fill in. We're like 1 episode behind, which we're going to drop this episode bomb on the listeners in the next couple of days, and then we have to get ahead because then we're both going to be traveling for a goodly part of July. So
Yeah.
Okay, cool. All right. Well, I'm ready to hit the record button.
Okay. I have everything actually set up correctly. I'm pressing record.
Okay.
I've pressed record.
I have also pressed record. It's working great. You're good?
Yeah.
Oh, okay. I was just waiting for the for the not in mono, etc. Okay, well let's get rolling then. Astronomy Cast, episode 308 from Monday, May 27th, 2013. Climate change. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. So we're now recording this after the Hangout-a-thon. So that was awesome. 32 hours of hanging out, of tons of special guests, and lots of fundraising for CosmoQuest and Astronomy Cast.
Yeah, we presented, it was originally just going to be 24 hours of guests and content and science, art, science fact, science, everything. But so many people wanted to take part that we ended up stretching it all the way out to 32 hours. And now I'm suffering from the fact that sleep is actually cumulative.
Mm-hmm.
So the fact that I slept 12 hours last night, my body doesn't care. It's still sleep deprived.
So if you miss the Hangout-a-thon itself, and you still, we still can take and still really would love to get your donations for CosmoQuest. So you can just go to cosmoquest.org/donate. And donate whatever you can and help get the word out. As you may or may not know, the new sequestration that's happening in the United States is having a big impact on education funding. So a lot of your funding for CosmoQuest is just getting pulled away.
So anything you can do helps, and we honestly, what we really need is help identifying corporations and grants that we can apply for funding from. We want your brains, we want your science, we need your dollars right now, but we don't want to have to keep asking.
Yeah, I think that's really the key, is that, our long-term goal here is for the thing to be self-financing through the services that we provide to you, through education, through classes, through really cool trips, gear, things that we can do that will provide you value, and then we'll make the whole thing self-funding and self-financing. And the writings has kind of been on the wall for quite a while that that you can't sort of depend on these kinds of grants for too long. So yeah, that'll be the future.
Yeah.
Okay, all right. Well, let's get rolling then. So when it comes to carbon dioxide, just a little goes a long way to warming the planet. And unfortunately, we've been dumping vast amounts into the atmosphere, recently passing 400 parts per million. Let's look at the science of the greenhouse effect and how it's impacting our global climate. All right, so I think the most important thing here is to kind of understand the greenhouse effect. What is this process, and what's the chemistry and the sort of the physics going on here?
The chemistry, I have to admit, I don't know the chemistry as well. That's not my forte. But
what is the biology of this? What is the numerology of this? No, no. What is
Let's start with the physics of this. The physics of this I can get to. So the basic idea is you have sunlight in all its different colors trying to come through our atmosphere. And our atmosphere quite successfully blocks the X-rays. It blocks the gamma rays. It blocks an ever-decreasing amount of the ultraviolet. It blocks segments of the infrared. It blocks segments of the radio. And the reason we see in what's called the visible part of the spectrum is because that part of the sunlight gets straight down to Earth. No big deal. Then that sunlight that gets through, it warms our air, it warms our soils, it warms our buildings, it warms us. But under less greenhousey conditions, a lot of that heat that gets built up from heating us up and heating the ground up, more importantly, is able to re-radiate and escape the Earth's atmosphere and go back out into space. Now, the problem is when you have greenhouse gases in the atmosphere, those gases block that infrared light. So when the warm soil and the warm oceans try to radiate away their heat, that heat bounces off the atmosphere, comes back, and it just builds up the heat on the planet. Greenhouse gases are simply like adding an extra layer of insulation that prevents the Earth's heat from escaping.
And so, can we see some analogies? We love your analogies. Where are some other places that we see this effect happening?
Well, Venus.
Well, okay.
So,
I was thinking, closer to home, cars, greenhouses, but things like that. Sure,
right,
yeah, no, absolutely.
right.
We'll
So,
go to Venus if that's where you want to go.
well, so this type of a chemical greenhouse effect is certainly on Venus. Here on Earth, people use the analogy of a greenhouse that you grow plants in, a hothouse all the time. And the way these work is the sunlight comes through, warms the air, and then the gas acts, which is apparently a word I can't say anymore, like insulation. And
But
that's
the
slightly
glass,
different.
right? I mean, the infrared can't get through the glass, right, of the greenhouse.
It doesn't thermally conduct the same way, so it's a slightly different circumstance. So you transmit heat in a variety of different ways. You can have the kinetic energy between the gas particles escape and interchange with the outer atmosphere. This is what happens when you have poor walls on your house, is the warm air in your house is able to escape and interact with the air outside. The air outside is able to come in and interact with the air inside, and the gas particles interactions cause the overall motion to, if you're hot inside, cold outside, well, having that cold air come in, it slows down the reactions of your hot air by exchanging energy. In this case, the warm energy, the high motion, goes to the lower energy. So there's several different ways that you can lose heat. You can lose it through infrared radiation, which is what we're failing to do here on the planet Earth. You can also lose it through just slowing down the particles, which is what happens when your house is poorly insulated. And when we talk about greenhouses, what is often happening with greenhouses is you simply aren't allowing that exchange of the particles inside getting heated up by the solar energy coming in, exciting the particles into moving faster, and then the outside ones. They're moving slower, and an exchange of those energies isn't allowed.
And that's why if you crack a window, it cools down really quickly.
Right. So this is different physics.
Right.
And this is where saying it's a greenhouse effect just bothers me.
Oh, really? Okay.
Because it's more than the greenhouse effect here on the Earth is due to a failure to be able to radiate away infrared radiation effectively. It's not due to the Earth's atmosphere failing to allow hot particles on Earth to interact with cold particles that don't actually exist in outer space.
Right.
So it's a pet peeve.
Right. It's a radiation problem, not a convection problem.
Yes.
Yeah, I understand. Okay, so and then you wanted to jump straight to Venus. So now I will permit it. Let's go talk about Venus, which is this process gone mad.
It's the end process, the end game in a lot of ways. We think that once upon a time, Venus may have had water on its surface. It was probably cooler, but as its temperature increased, you end up with this twofold problem of, first, as the temperatures increase, you end up with more and more humidity able to be supported in the air. the more and more humidity is supported in the air. Well, water vapor is another greenhouse gas. It does more to help trap in that infrared radiation. You trap in more of the infrared radiation, more of the water evaporates. Eventually, you end up evaporating away your entire ocean, and that just continues to lead to the runaway buildup of heat on the surface of the world. And with Venus, you have the carbon dioxide, carbon monoxide, water vapor, all of these different gases. And so when we talk about greenhouse gases, the one that is most notorious is the carbon dioxide we have here on Earth, but it's not the only one. It's just one of many.
Yeah, and I mean, green with Venus, you've got the situation where the atmospheric pressure at the surface of Venus is like 92 times the pressure of Earth. I mean, it
Yeah,
is, and the temperature there is 735 Kelvin.
brutal.
It's a hot, yeah, it's a hot place. Now,
Right.
but how much of that heating is happening from the fact that it's carbon dioxide, and how much of that is just like the weight and pressure of all that atmosphere? Is that having an impact as well?
Well, the weight and pressure of the atmosphere in this case, um, yeah, that's going to have some effect on the temperature. That's the standard gas law. Gas law: the higher the pressure of the gas, the higher the temperature of the gas. But it's not going to account for 900 degrees Fahrenheit of the
Yeah.
gas. So, yes, that plays a role, but the major role is played uh, by the trapping of the solar radiation, which allows the planet to warm up, which allows the atmosphere to stay warm because the radiation can't escape effectively.
And if,
It's
if I recall correctly, way back when about our episode on Venus and talking about plate tectonics, that that it's possible that the high temperatures on Venus have actually just shut down the whole plate tectonic cycle on the planet, preventing I guess, the sequestration of the carbon, right?
Well, it's not that simple. I mean, you also have the fact that Venus isn't rotating as quickly as other worlds, and without that rotation of the inner core, it's harder to have plate tectonics. Um, but yes, having the atmosphere that it has, the carbon dioxide does stay in the atmosphere instead of getting rejuvenated through life and through tectonic processes, through rocks and things like that, to go back under the surface.
All right. So now back here on Earth, we know that the amount of carbon in our atmosphere rises and falls naturally over long periods of time. We know that the temperatures rise and fall naturally over long periods of time. So there is this natural cycle that's going on, but what are we doing to unbalance it?
Well, there's a whole series of different cycles that go on at any given time. There's cycles due to the slight changes in the ellipticity of the Earth's orbit that vary how far and how close to the sun we get over the course of our orbit. And because the way orbits work, when you're further from the sun, you're moving slower. That can have global impact. It has to do with slow changes in the tilt of the planet. Don't worry, we're not going to flip on our side the way some crazy people think, but the planet's tilt does ever so gradually change small amounts. It has to do with the precession of the pole of the planet. But all of these are gradual, long-term processes with known cycles. There are other cycles on top of that are harder to predict. The sun misbehaves. There was a period called the Mater minimum where there weren't the same numbers of sunspots that have been seen at other points throughout the hundreds of years that we've been studying sunspots. And during that Mater minimum, that period of lack of solar activity, the Earth experienced a mini ice age, especially in Europe. This was tied in part to what caused the Dark Ages and famines and many other issues that were experienced in Europe. But then on top of that, right now we see, okay, we're measuring the solar radiation. That isn't sufficient to explain the increase in temperatures that we're seeing on average across our planet. We're seeing drastic melting of glaciers. We've seen that in the past on Earth in various records, but the rate at which it's occurring and the timing at which it's occurring are unusual and hard to explain. But then when we start looking at the levels of carbon dioxide in the atmosphere, it's increasing at a rate that hasn't really been seen in the past. And it's this sudden, sharp increase, and the way it's behaving that just doesn't look like anything that we've seen in the tens of thousands of years of data that we've been able to retrieve from ice cores, from ground cores, from looking at trees. That doesn't get you the tens of thousands, but still. And so this seems to indicate that our planet is suffering, is sick in a way that we haven't seen before. And when we start to look at how long-term colonies of life that are highly sensitive to their environment are starting to die off, it indicates this is something that is new within the period of industrialization. When we look at coral reefs, which are sensitive to temperature and pH, when we look at freshwater lakes that are sensitive to temperature and ultraviolet light, when we look at where animals are currently migrating compared to all oral and written histories of various places, all these things are changing.
Yeah, and when you see, I mean, that's one of the most stark graphs that I think I've ever seen is this one, every year the sort of during the summer for the northern hemisphere, the sort of all the plant life grows and absorbs carbon out of the atmosphere, and then I guess it, stops happening in the wintertime. And so you see this cycle, this sort of, rise and fall of atmospheric carbon, but instead of it being this sort of ongoing like sine wave, it's actually this stepping up that just keeps going up and up by this really sort of precise amount every year. We're really seeing this amount of carbon dioxide in the atmosphere just going up in this very set amount. And as I mentioned sort of in the intro, we've crossed the 400 parts per million mark just this year, right?
And there's other concerning gases. There are people who are deeply concerned, and the research is out on this one. I recognize that this is an open question at this point, but one of the open questions that's being looked at right now is we know methane is a greenhouse gas. We see its effects on Titan. We see in our own geologic history how methane in the Earth's atmosphere allowed us to be a warm world when our sun was 70% cooler in the distant past. When the sun gave off 70% of its current energy in the distant past when it was 30% cooler. We are now releasing methane into the atmosphere at a new rate that hasn't been seen in the past due to things like fracking. Methane is generally collected and used in things like our dryer runs off of methane, for instance. It's a natural gas and we can use it for things. But the amount of it that's escaping into the atmosphere, it's another form of greenhouse gas. And the question is being asked, is fracking leading to a precipitous release of methane that is also of concern as we look at the global warming effects?
Yeah, now global warming is sort of the way most people described it, but I think, the newer name that we used, the climate change, I think is a lot more accurate. But let's talk about the warming first. So far, since people have been keeping track of this, about how much has the planet warmed?
Reports are of several degrees. The ones that I was looking at earlier today is about 4 degrees, which doesn't sound like a lot, but it's enough.
We're up 4 degrees already?
Mm-hmm.
Since like what time frame?
Oh, that's a question. I just looked at the ultimate number, not the how long. Sorry, this is going to need to be edited, Preston.
Yeah, I figured not how much will we, but how much have we already, like, isn't it like half a degree in the last 100 years or so?
Sorry, I don't have it in front of me.
Do you?
Sorry, this is where you learn that I don't know everything.
I need all the numbers in your brain at all times.
So in the last 100 years, and I was looking at something that spanned far more than 100 years, that of course isn't in the history on this computer, it's gone up 1.3 degrees in the past 100 years.
Okay.
But I want to say it was 4 degrees since the lowest low to what it is now.
Right, but
but let's go with this number.
sure. Will you do
Okay.
the 1 point? Yeah, that sounds
Yeah.
fine.
Okay. Sorry, Preston. You're going to have to edit the tar out of that bit. Okay. And must remember cameras here, words here. Sorry for my eyes going all over the place, audience.
Okay.
Okay. Re-ask the question.
Right. So how much have the temperatures gone up already? Kind of since we've been keeping modern measurements.
Right. So in just the past 100 years, and the temperatures have been much colder in the past, but in just the last 100 years, the folks at UCAR have measured that the temperature's gone up 1.3 degrees Fahrenheit. And that doesn't sound like a lot, but it's enough that we can start seeing major changes in glaciation. It's enough that we're starting to see the northern passage through the North Pole essentially becoming saleable, perhaps even year-round in the next couple of years. But the idea that you could ever sail through that's not something we ever really imagined would be possible.
And I don't know what 1.3 degrees Fahrenheit is in Celsius.
0.74
0 points.
Celsius.
Okay, great. Thank you. I'm sorry. Yeah, I'm bilingual in weight and temperature. Sorry, in distances, but I metric in terms of temperature.
No, it's all good.
Right. Okay. So, and as you said, right, we're already seeing the implications. I mean, many of the hottest years on record have happened within the last decade. The polar ice cap is now, free of ice, or big chunks of it are free of ice every
Yeah.
year. Glaciers are melting at a larger rate. But I think, I think as I mentioned, a little bit ago, that it's this transition, this terminology from global warming to climate change, I think makes it a lot more accurate, because it's not necessarily going to be global warming for everybody,
No,
right?
no, and that's actually one of the harder to stomach parts of this when you start looking at the climate models. We live on a planet that is in many ways a very finely tuned machine. Um, we have the mid-ocean conveyor belts that transport the warm waters from the equatorial regions north to, the colder regions on the North Pole, and south to the colder regions near the South Pole. And these mid-ocean conveyor belts are in part driven by salinity, in part driven by temperature, but the salinity of the ocean is what allows them to stay in balance the way they are. So if you change the salinity of the ocean, you can shut down cold. That wasn't meant to be a pun, but you can shut down cold turkey the mid-ocean conveyor belts. This would have the effect of temperate climates like England suddenly becoming significantly cooler because they're not getting that warm water circulating up toward them. There are those in the scientific community who are looking to try and understand if the recent snowfall that's been measured in England is an early sign that this is starting to happen, and the significant cold snaps that happened in Northern Europe this year, if that is another sign that this is starting to happen.
Snowmageddon.
Yeah,
Yeah,
yeah.
but and of course, part of the problem with this is that at any point, I mean, you look at the last year, 2012 in the United States was just a disaster across the whole country. I mean, you had horrible
Mhm.
droughts, terrible flooding, terrible wildfires,
Yeah. A tornado
tornadoes.
2 blocks from my house.
Yeah, well, that was 2013.
Well, yeah.
Yeah, hurricanes and so on and so forth. So you have all of this increased weathers and storms and all these
Yeah.
problems. So it's very unpredictable. But at the same time, it's really difficult and essentially impossible to connect any one of those events and say, okay, fine, the hills are
But
on
this
fire.
is,
Is this our climate change? Is this global warming?
yeah.
You know?
And what you have to do is look at it globally. You have to look at what are the models for how the temperature buildup and release at various places is allowed to occur. Where are the hot spots? Where are the cold spots? How is this affecting moisture transport in the atmosphere? How is this affecting the thermal gradients? Massive storms are driven by the thermal gradients of hot and cold in different places. And if the equatorial regions are able to build up higher and higher temperatures, that's going to lead to increased thermal gradients and increased storm power. It's one concern that's been expressed is that this could end up leading to more Category 5 hurricanes and typhoons. Um, so what we
Right.
have to do is track long term. Do we see an increase not just in the global temperature, but do we also see an increase in the temperature gradient between the poles and the equator?
Yeah, I mean, the kind of terrible irony is like for where I live, we're expected to do quite well from
Yeah.
climate change. It's kind of cold and very wet and is expected to become warmer and drier
Yeah,
where I
you live
live.
in the northern rainforest.
And so, for a lot of species, there'll be, not as much rainfall as they would appreciate, but it'll become more Mediterranean-like. I don't know, more like Northern California. I mean, so the
Yeah.
point is that it's going to get so it's but for the vast majority of people, I think it's going to be it's going to be worse because you're going to end up with, you know, all of the resources that you count on are going to start to change and shift and things are, and then you've got these natural disasters on top of that. So
Right.
now I think right now, the carbon continues to be put out into the atmosphere,
And methane and
and
other
methane
greenhouse
and water
gases.
vapor and
Yeah.
other nasty greenhouse gases, what kind of temperature rises could we expect in the future?
Looking at different studies, pretty much everyone says somewhere between 3 to 7 degrees increase.
Now that
Um,
doesn't sound like the end of the world. A 3 degrees rise, a seven
right.
degrees rise, that'll
Well,
be a little warmer.
that's in the next 100 years. And the issue is when that happens, you end up with loss of glaciers, which leads to the end of salinity in the ocean. Well, not the end of, but a
A change, yeah.
significant, yeah, it leads to a significant change in the salinity of the oceans, leads to the loss of this mid-ocean conveyor belt, which leads to massive changes in weather patterns and temperatures in various areas, which leads to greater extinctions, which leads to, do I need to keep going?
No. That's fine. I think we understand. And you
Right.
have, and there's the potential of other even more unforeseen things like, there are vast reserves of methane locked in the permafrost of Canada.
Right.
And if that stuff
That's a
all heats
concern.
up, then that could all just seep out into the atmosphere, and you could get these cycles. So, you know,
And you end up with collapse of different economic, not economics. Well, you end up with that too, but different ecological niches, loss of the um, all sorts of different water creatures. That's the one that's most disturbing because this leads to a change in the pH of the water, and it also leads to a change in temperature of closed bodies of water and of bodies of water where the animals don't have the ability to necessarily migrate. So, critters living on a coral reef. They can't just hop to a slightly more northern coral reef and keep hopping north because eventually they hit waters that don't currently have coral reefs.
right.
And so this is vast food stores here in the United States and in Canada. We don't live off of local fish, but for all the different nations in the world where they're still living quite well, but less and less well every year off of the oceans, it's going to become harder to survive.
So, what strategies have been proposed to be able to actually, deal with this and try and get the carbon levels in the atmosphere back down to some kind of reasonable level?
There's lots of things that vary from behavior changes to drastic changes to our planet using technology. So there are those that have suggested everything from we need to deploy a bunch of little tiny umbrella satellites that shade our planet to a certain extent, thus preventing significant portions of the sun's light from getting to the planet. There are those who have suggested that we need to trigger massive algae blooms in the ocean so that they absorb carbon dioxide out of the atmosphere. And then there are those who, rather than trying to manufacture change, suggest that we simply change our behavior so that Mother Nature can take care of itself and heal while we stop adding new. So there's the movement to eat less meat, not because meat is immoral, but because, or at least immoral on the animal side of things, but because it's irresponsible because of the amount of carbon emission tied into the whole raising up cattle, raising up chicken raising a pig process. There are those who argue we need to never use things like Amazon Prime 2-day shipping that leads to packages getting shipped air all over the world instead of using the more efficient means of trains and barges. There are those who argue that we need to eat local and eat in season. So you shouldn't be eating tomatoes in January unless they happen to come from a local greenhouse. We don't need those Fuji apples in any time if you live in the north. All of these solutions have significant economic question marks. We are finding that in general, it's actually more cost efficient to decrease and be more efficient to eat locally. But the transition period is always hard, and I think people live in fear of that change.
No, I mean, the good news is that carbon dioxide is a very volatile substance in our atmosphere, and it doesn't really want to stick around. And I mean, I
No.
think that if you let the planet sort of do its own thing and we're not adding to the carbon footprint, it will decrease naturally on its own, right?
And methane's even more sensitive. It just
Yeah.
breaks down in ultraviolet light. So yes, if we can find a way to stop releasing significant amounts of carbon dioxide through a combination of moving to greener energies, greener transportation methods, greener ways of eating. I say this as a meat eater who uses Amazon Prime at least
Yeah,
once a
it
month.
flies quite a bit. Yeah.
Yeah, I live with a significant amount of guilt every day. Um, but if we can swallow up the inconvenience that we seem to think is too much, if we can swallow that and change our behaviors, I think we can heal our planet. Well, no, we can't heal our planet. I think our planet's natural ability to return to equilibrium will hopefully prevent too much further damage from coming. Some damage is done. Some species are gone, or may reach the point that they don't have the genetic diversity to return.
Yeah,
But
now I mean we think about the long term here on Astronomy Cast.
yeah,
Sometimes, a one followed by 100 zeros if
yeah,
necessary. And so I think it's really important for people to understand that the planet will be fine over the long term. And there'll be times when it won't, like when a massive asteroid crashes into it and destroys
hmm
99% of the life on Earth, like it has in the past. That in 5 billion years the sun will blow it up and blast it with radiation. So we're really talking about ourselves here. We're talking about the species that are here with us right now,
yes,
and sort of what it's going to be like for human beings. This is kind of a moral imperative
hmm
for our sort of fellow human beings. Not like we need to save the Earth. The Earth is going to be just fine. The Earth didn't care about us
it's
before, and
the
it won't.
current,
It is the
it's the
current
current
state.
ecology.
Yeah, it's the current ecology. That includes us, that we depend on so much, and that's what's at risk
Right.
is human beings.
Well, I wouldn't say it's just human beings. I mean, I have to admit, I'm one of those people that can get over emotional about the penguins and the polar bears if you just pick your pole of concern. Um, both those species are struggling. And the fact that polar bears are starting to be discovered crossbreeding with grizzly bears because for the first time in record keeping, their territories are starting to significantly overlap. That's a really weirdo side
Yeah,
effect
yeah.
of changing
Bear
climate.
change. Yeah, yeah.
Yeah, yeah. So I don't know what you call the offspring of a grizzly and a polar bear other than not something to get near.
So,
Um,
all right. So now maybe you should use standard shipping with Amazon from here on out, and other
or
stuff.
just buy local. I mean, I'm lucky enough to live in a small town where, for the most part, I can get anything I need from a family owned store that is, well, a lot of times getting from local manufacturers.
Yeah, and
And
I work from home,
yeah,
which is great, except for the part that I never leave my cul-de-sac. But other than that, it's good that I don't have to like commute to work. So I think there's a lot of technology is gonna make a big impact. We just need to embrace it as it's coming down
Right.
the road. These new kinds of energy, these new kinds of devices, these new cars, all this kind of stuff. So, all right. Well, thank you very much, Pamela.
Thank you. It's been my pleasure. Okay, saving. Do you want to go straight into the next episode and then take questions?
Yeah, let's do that because we got a bit of a late start.
Okay.
I don't know if people want to follow us into the next one.
Well, they're going to get a new link, I think. Or are you just going to embed this one into the next one?
I kind of want to start the other one up so that it sort of breaks it up properly.
Okay, that sounds
Yeah,
good.
yeah.
Okay,
So,
cool.
let me see. I didn't see a lot of questions here. Chris Factor says, greener energy will make it possible to get energy to places that don't have it. Current oil coal methods won't fix this.
No.
What about temperature rise and earthquakes heating up the plates? Do you think there's we're way far away from, having what's like what's happened with Venus, right?
Yeah.
And the climate isn't going to change the plates at all, right?
No.
Hey, Pamela Gay's awake, says Jim Meeker.
Yes, I am.
Yeah, Randy8118 says, if only we could take the CO2 from Venus and move it to Mars and make 2 habitable planets. That would be awesome. You wouldn't have to take much either. You'd have to take 1% of the the Venus atmosphere and take it to Mars.
You'd want to take more than that because it would deplete itself rather quickly. Give
But would
yourself
it
a
though?
running
Because
start.
wouldn't carbon dioxide it's going to stick to Mars better than air. Air, the hydrogen will get knocked off and the air is going to, the oxygen will go away. But if you take carbon dioxide, that's going to stick around like a
Carbon
like a
dioxide
blanket.
is air. Just to be clear.
Well, no. But I mean, you're not going to, you can't breathe it, right?
No, so I think you mean oxygen.
Well, no. I'm saying carbon dioxide. You take carbon dioxide from Venus,
Right.
and you pipe it off of Venus, and you drop into the atmosphere of Mars, which already has
Yes.
a very thin carbon dioxide atmosphere.
Yes.
And so then what you get is a very thick carbon dioxide atmosphere on Mars.
Which will still get depleted over time. So I'd say just make it extra thick. Let it stick around a little
Sure,
bit longer.
but isn't the depletion of the atmosphere coming from the fact that the hydrogen atoms are getting knocked away from Mars, into space, while carbon dioxide is a
But
lot heavier and would sort of stick around.
they're all getting knocked off. It's just those are getting knocked off more slowly.
Oh, okay, all right.
I mean, we lose hydrogen and helium out of our atmosphere as well. That's why helium's a scarce
Right,
resource, and
right.
we're going to eventually run out of helium.
Yeah. Okay. Eric Charlin says, "Damn, I had no idea you had one before 3:09 at 11 p.m." This is the first time we've ever done this. So
Yeah.
we're actually going to do another one right now. So if you go back to the event page, go to the Astronomy Cast event page, and there's episode 309. We'll do that one right away. So why don't I wrap
Okay.
this up, and I will just reformulate it, and we'll get rolling again. We got to do a bunch of links and other stuff like that, and then we'll
Yeah.
get rolling with the next episode.
Okay.
Okay.
I will await your ring
Okay.
and start sharing now.
Okay. Thanks, everybody.
Bye-bye.
And stop teasing us. So I think that's what we want to try and encourage. The other part that you should know is this is an interactive experience. So we're going to record Astronomy Cast, and we will probably make a bunch of mistakes, and you get to watch that, which is always hilarious. But if you want to suggest any ideas, if you want to ask us any questions or want to make some comments, you absolutely can do that. Just you can post your comments. If you're watching this on the event page on Google+, you can post a comment there. If you're watching this on the in my stream, you can post a comment there. If you're watching this over on YouTube, make a comment there. Or if you're just watching this somewhere else and you just like Twitter, then just use the hashtag AstronomyCast, and we will catch all of those locations, I hope. I also want to remind you, if you're watching this, to just click subscribe in whatever YouTube you are experiencing this in. So, all of the shows, they start out on my feed, and then they end up over at Astrosphere Vids. So either, subscribe at Universe Today on YouTube, but also subscribe at Astrosphere Vids on YouTube, and that way you'll get the
Yeah.
sort of the nice full sort of archive of all of our videos. So, and then as new ones are posted, you'll see them there. Not that we don't. Is this your first thing after the Hangout-a-thon?
First thing after the Hangout-a-thon and dealing with about 900 of the 1,500 emails I got over the weekend.
Yes, yes. Not only can you not put your life on hold over those kinds of things, but in fact, it creates this gigantic black hole of time.
Well, vacations do the same thing, and if
Yeah.
I'm going to be punished for taking time off, I'd rather have the time away from my computer be something that helps my job rather than something that simply leaves me feeling like, oh crap, I can't leave my job behind ever.
I always envy those people that can like take actual vacations and other people do their jobs while they're gone, you know?
Yeah, we aren't those people.
No, we're not. No, no. If I leave, I get, 200 or 300 emails a day. And so if I leave, then they're waiting for me.
Hmm. And you still have to answer them. And, no matter what away message I put up, they'll start like sending me emails that say urgent, that say
Urgent.
respond immediately. And if I'm not there, I'm not there.
But anyway, congratulations on
Thank you.
32 hours of hanging out a thon madness. And
Yes.
I watched as much as I could. I participated as much as you'd let me. And you guys did a great job.
Thank you. Thank you. It was a long weekend, and we still have a long road to go on our fundraising, but we hit 10% of our total goal, which is pretty good.
Yeah, it was great to see everyone's support. There was a few really great guests who were able to really help with the fundraising. So no, I thought for the first time, we've done this kind of a thing. I think you guys did a great job. I'm really
Jeff
impressed.
Notkin, one of the Meteorite Men, more than anyone else, came on and fired up the audience. And Michael Foister from Astronomy FM, he was there behind the scenes for
Yeah.
almost the entire 32 hours. He stopped to go do his day job, but Astronomy FM, they were huge supporters both on the technical side, and then they also rebroadcast everything we did. And some of that must have been really weird on radio, for instance, when I completely failed to make cake pops that look like planets.
I caught that part.
Yeah, yes. That was just bad.
So we're going to record 2 episodes now. Also love the audio listeners as well, as we're trying to streamline the whole process. We're almost caught up actually by the 2 episodes we do tonight, and there's one that we've got sort of to fill in. We're like 1 episode behind, which we're going to drop this episode bomb on the listeners in the next couple of days. And then we have to get ahead because then we're both going to be traveling for a goodly part of July. So
Yeah.
Okay, cool. All right. Well, I'm ready to hit the record button.
Okay. I have everything actually set up correctly. I'm pressing record.
Okay.
I've pressed record.
I have also pressed record. It's working great. You're good?
Yeah.
Oh, okay. I was just waiting for the for the not in mono, etc. Okay, well let's get rolling then. Astronomy Cast, episode 308 from Monday, May 27th, 2013. Climate change. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me we're going to record, right now we're going to do an episode on climate change, and we tried to do one during the Hangout-a-thon, but I think the audio wasn't very good, and our guest wasn't exactly sort of prepared in sort of the way we tend to do our episodes, so we're going to sort of take another crack at the climate change now.
Yeah, our guest was good. We were the ones, we didn't prepare her for how we normally do this as let's discuss the science facts. So she took it from a much more pragmatic sociological perspective. And
I love to have that conversation too, but it didn't really feel like it was going to fit with the Astronomy Cast. Yeah, so it's still in the feed for the Hangout-a-thon, but we're going to do the sort of the science side of it. with this episode.
You know, I just realized my cup's completely empty. I'm going to run to the other side of the wall and back with
Okay.
some water.
All right, well, then I will continue my various spiels then.
Okay.
Right, so then after that, we're going to do another episode on creating a sciencey society. And I think this is something that's quite near and dear to all of our hearts, which is like, how do we get people more enthusiastically engaged in science? Not necessarily just astronomy, but just all of the sort of wonderful benefits of science that we all live and experience. How can we get people to really kind of appreciate it and encourage it and